Lesson 3, function notation. So function notation is a notation used to show the independent variable of a function. So first let's just talk about what a function is. So if you take, say, this box, we're going to call it function f. If we take an x and put it in here, something's going to happen to it. And when it comes out, it's going to become f of x. And that's how we say it, f of x. So if we say that this function multiplies everything by 5. If we take a 2 and we put it in here, we know it's going to multiply by 5 and come out as a 10. If we take a 3 and put it in here, it's going to multiply by 5, come out as a 15. If we put an x in here, goes into the box, comes out as 5 times x. So the f of x, function of x, would have been equal to 5x. So that's how we write it in function notation. So the function evaluated at x is what it stands for. So the function of x. So we're going to write in function notation. So right now we have two variables. We have a c and an n. We want to write c evaluated at n. So this way it's still, now it has to do with n. So c evaluated at n is equal to 300 plus 30n. So now we really only have one variable, and c is in terms of n. So this is function notation. And this is two variable notation. Now we want to be very clear about what our independent and our dependent values are. So our dependent value is dependent on what n is. So c, or c of n, is the dependent, meaning n is our independent. So we always put our independent variable inside the brackets. So we're going to evaluate now. So if we look at our first example, the 20 is replacing n. So we're going to replace n in the entire equation. So 30 times 20. Now all we have to do is we have to evaluate. So 300 plus 30 times 20 is 600. So c of 20 is equal to 900. In this one, 750 is all of c of n. So we're going to replace all of c of n with 750. It's like replacing our answer with 750. So 750 is equal to 300 plus 30n. Now we isolate the variable. So we're going to minus 300 from both sides. So we're left with 450 on the left side and 30n on the right side. Now we isolate n by dividing by 30 on both sides. And we should be left with 15 is equal to n. So that is our solution. The next example. We have the equation v is equal to negative 0.08d plus 50. Represent the volume, v liters, of gas remaining in a vehicle's tank after traveling d kilometers. So first we want to write this in function notation. So we have v bracket d is equal to negative 0.08d plus 50. Our independent variable is d inside the brackets. So it's distance. Our dependent variable is v. volume. Now we're going to evaluate V of 20. So 20 is replacing D, so we're going to replace all the D's with 20. Except I wrote it wrong. There we go. And now we just evaluate. So this is negative 1.6 plus 50. So our final answer is 48.5. So what this means, this is liters, is after 20 kilometers, you will have 48.5 liters in your tank. That's what you were solving for. After 20 kilometers, you will have 48.5 liters in the tank. Now we want to solve for V of D is equal to 49.6. So we're going to replace the entire answer with 49.6. So 49.6 is equal to negative 0.08 D plus 50. So we're going to minus 50 from both sides. We should be left with negative 0.4 equals negative 0.08 D. Isolate your variable and divide by negative 0.08. And you should be left with 5 is equal to D. So you will have 49.6 liters after 5 kilometers. That's what that means.